So I'm Dr. Lutz Mary, Associate Professor in the Department of Computer Science and Engineering. I'm going to take the topic virtualization of memory and I/O devices for the subject computing. So first I have to know what's the hardware support needed for this. Modern operating system and the CPU permit multiple processes to run simultaneously. So all the CPUs have at least two modes, user mode and supervisor mode. Instruction running in supervisor mode are called privileged. Other instructions are called unprivileged instructions. VMware workstation is suitable for x86 64 computers. So KVM, kernel based virtual machine, is a Linux kernel virtualization infrastructure. First we will see what is memory virtualization. Virtual memory virtualization is similar to the virtual memory support provided by modern OS. In a traditional execution environment, the operating system maintains mapping of virtual memory to machine memory using page tables, which is a one-stop mapping from virtual memory to machine memory. That's a physical memory. However, in a virtual execution environment, so virtual memory virtualization involves sharing the physical system memory in RAM and dynamically allocating it to the physical memory of the virtual machine. So mapping between two physical memories. So that means a two-stage mapping process should be maintained by the guest OS and the VMM or hypervisor respectively. So virtual memory to physical memory and physical memory to machine memory. So schematically we will see how it will look like. So Intel hardware assisted CPU virtualization. So you will be having the VM control structure, again VM entry and exit point. So VM control structure configuration, then VMM or the hypervisor memory and I/O virtualization. That is the one we are seeing now. So above that you will be having ring 0 to ring 3 WinXP, and that's an operating system. Above that we will be having an application layer. So memory virtualization is similar to virtual memory supported by modern OS. So two-stage mapping process should be maintained by the guest OS and the hypervisor respectively. So virtual memory to physical memory and physical memory to virtual memory. As a virtual memory one, how it look like. So it's a two-level memory mapping procedure. So in the first VM we will be having process 1, process 2 and so on. So the virtual VA memory and physical PA memory. So machine memory is denoted by ME. So all the processes will be mapped onto physical to virtual memory. So each page table of the guest OS has a separate page table in the VM. Corresponding to it, the VMM page table is called the shadow page table. So if you are familiar with an operating system subject, then you can easily understand. So main memory unit already handles virtual to physical translation as defined by the operating system. So VMware shows shadow page tables to perform virtual memory to machine memory address translation. So CPU uses a translation look-aside buffer hardware to map the virtual memory directly to the machine memory to avoid the two levels of translation on every access. Next we will see what is I/O virtualization. It involves managing the routing of I/O requests between the virtual devices and the shared physical hardware. There are three ways to implement I/O virtualization: full device emulation, para virtualization, direct I/O virtualization. So we will see one by one. First we will see what is full device emulation. All the functions of a device are bus infrastructure such as device enumeration, identification, interrupts and DMA are replicated in software. So it is schematically represented. So it's a real device. So device will be need a device driver. Above that you will be having I/O stack. Then the device emulation will be done. So that will be communicated with the device driver of the guest OS. The device emulation has a virtualization layer. The entire thing, the virtualization layer will contain the device driver for that particular device. Real device may be different from a virtual device. I/O stack, device emulation. What the virtualization layer has, it emulates a virtual device, remaps the guest and real I/O addresses. It multiplexes and drives physical device. The I/O devices consist of COW disk. I/O virtualization. So next is para virtualization consisting of front end driver and back end driver. The front-end driver is running in domain U, and the back-end driver is running in domain 0. The front-end driver manages the IO request of the guest OS. So back-end driver is responsible for managing the real IO devices and multiplexing the IO data of different virtual machine. The third technique is direct IO virtualization. Let the VM access the device directly. It can achieve close to native performance without high CPU cost. Next is self-virtualized IO, that is SVIO. All tasks associated with virtualizing an IO device are encapsulated in SVIO. It provides virtual devices and an associated access application programming interface to VMs and a management API to the virtual machine monitor or a hypervisor. It defines one virtual interface for every kind of virtualized IO device, such as virtual network interfaces and virtual